Bismillahirrahmanirrahim. Okay, students, our next topic is Simpson's 1 by third rule. So, in what's the difference between this and the trapezoidal rule that we have already discussed is that in trapezoidal rule, you are going to have a function, a curve f of x that is defined by a function f of x, and that is passing through only 2 points like this x0 and x1, and you are going to estimate it via a straight line passing these 2 points. This is known as trapezoidal rule, right? But when you talk about Simpson's 1 by third rule, then in this case you have a function that is defined by a curve, and this curve is passing through 3 points. As you can see that x0, x1 and x2. And in this case, you are going to estimate it by a polynomial of degree 2. And of course, it would be something like parabola and this kind of thing. And in this case, you estimated this curve by a polynomial of degree 1, and that was defined by a straight line. And in this case, we are going to have a parabolic type of curve that we are going to estimate it with this function f of x, because we want to estimate it by the known curve, this function, right? We are going to estimate the behavior of this function via known curve, whether it's a straight line, whether it's a parabola or something like that, or cubic curve, right? So in this case, what we will do, if we are going to have this integral, and this is the definite integral, of course, a to b f of x dx, and this is a curve, and we are going to estimate it by a polynomial of degree 2, and that is the Lagrange's interpolation polynomial p2 of x, and that is passing, of course, through 3 points. In that case, since trapezoidal rule, we had only 2 points, and in this case we have 3 points. Then of course, so the initial point would be x0 is equals to a, the starting point, and then there would be an interval of h, because I already told you that we are going to discuss all these rules when we have equally spaced data. So there would be an interval h. So x1 is equals to x0 plus h, and then x2 is equals to x0 plus 2h, and this would be the final point. Okay, and here the step size h is equals to b minus a divided by 2. In that case, we had h is equals to b minus a over 1, because the general form is h is equals to b minus a over n. In the first case, we had only one interval like x0 and x1, and in this case we are going to have two intervals, because x0 comma x1 and x1 comma x2. So of course we will be having two intervals. In this case, with 3 points we have two intervals. So when I put n is equals to 2, then I would be having h is equals to b minus a over 2. Okay, so I'm going to split it with the two intervals, and over here you can see that x2 minus x0 over 2, that is equals to h. So this would be the final point, right? Now for n is equals to two intervals, I'm going to approximate this curve x0 to x2 f of x ds in this by this polynomial, Lagrange's interpolation polynomial p2 of x. So as we did in the previous lecture, that this x0 to x2, since I am going to have Lagrange's interpolation polynomial, then I would be having L0 y0 plus L1 y1 plus L2 y2, and y2 would be function f of x at the point defined at the point x2 into dx. So just expanding these terms L0, L1 and L2, you know that L0 would be x minus x1 into x minus x2. You are not going to write x0 in this case, and when you divide, you will be getting s0 minus x1 into x0 minus x2 instead of this x. So this the multiplication of this would be giving you a polynomial of degree 2. So now as we did earlier, x naught, of course, is final initial point A. This is the final point, and the difference x1 minus x naught I'm taking over here to be h. Uh, and then x2 minus x naught would be 2h. This is not difficult because you can see over here x1 minus x naught would be h, and x2 minus x naught would be equals to 2h. So if you have n intervals, then it would be xn minus x naught is equals to nh. Okay, so with these substitutions you are going to express your function, your variable x in terms of p, as we did earlier. So I have this expression x minus x1, x minus x2, x minus x naught, and x minus x2. I'm going to calculate all these variables in terms of p. So x2 minus x naught, if I would like to have this, then it would be x2 minus known value. आप यहाँ पे जो known value है x naught उसको लिखेंगे x1 minus x, यानी कि यहाँ पे वो you will be writing this instead of x naught, you will be writing x1 minus x h, right? And when you do this, it would be x2 minus x1 plus h. Okay, now this implies that this 2h is equals to x2 minus x1 plus h. x2 minus x1, now this would be equals to h. ये वैसे भी यहाँ से जो है निकल, ये किया क्या है, what we have done, left hand side x2 minus x naught, this is already equals to 2h. We have taken this interval because we know that this is x2 minus x naught, that is equals to 2h. So what I am going to do, पहले मैंने इसको यहाँ पे लिखा है, x naught इसका यहाँ से हटाया है. Now this, ये जो right hand side वाला expression था, that is equals to x2 minus x1 plus h, और ये x2 minus x1 that is already equals to 2h. So what I am going to do, x2 minus x1 that is equals to h. What I did, instead of this x naught, I have involved x1 in this case, right? x2 minus x1, now this is equals to h, because initially I had x2 minus x naught is equals to 2h. So of course x2 minus x1 would be equals to h. This is the difference between 2 points, that would be equals to 2h, and this is the difference between the successive points 1 and 2, then that would be equals to h. Okay, now initially I would like to have this, if x is equal to x naught plus h plus pa into h, then of course dx would be equals to h into dp. And with this, as we did earlier, we are going to have all these expressions, x minus x naught would be equals to ph, and then I have to find all these expressions in terms of p, as I already did. In this case, I would be having x minus x1 is equals to p minus 1, because I in trapezoidal rule I calculate the value of x1 minus x naught. Similarly, on the same lines you can do calculate these values, right? Calculate the values of x minus x1, that would be equals to p minus 1, and x minus x2, that would be equals to p minus 2, right? So when you substitute all these expressions, then you would be having these variables, and the interval would be 0 to 2, because in that case you had the interval from 0 to 1, x naught to x1 in the trapezoidal rule, and so we got the values 0 to 1. And now in this case you are going to have the interval x naught to x2, so you would be having these values 0 to 2, because over here you can simply see that if I put x equals to x naught, then I would be having p is equal to 0, and if I put x is equals to x2, then it would be x2 minus x naught over h, and x2 minus x naught, that is equals to 2h. So h will get cancelled out and you will be left with p is equals to 2. When you will do it this thing in black and white, then it would be easy. It's not that much difficult, right? You have already done it in the previous lecture. So when you have all these variables in terms of p, just integrate it, put in the these values, take the constants out, and then you will see that when you will integrate this expression, you will be getting the final points, because you are going to put the values of p in this case, and you will be left with only h by 3 f of x naught plus 4 into f of x1 plus f of x2. You can write this f of x naught as f naught plus the final point f2 plus 4 times f of into f1, right? So this is the Simpson's 1 by third rule. And in this we had only two intervals. So if you are going to split this curve in n intervals, you would be having this general expression as h by 3, the initial point plus the final point plus 4 times the odd values like 1, 3, 5, 7, and plus 2 times the even values like if it is f naught, then it would be plus 4f1 plus 2 into f2, and then if you have the final point as f3, then it would be in this case, right? Similarly, of course, they are, since we are going to approximate the curve, so there would be errors. So the errors, that would be the local error, the Simpson's 1 by third rule. The local error would be of this form, and this function needs 4 derivatives, right? An exact belonging to this value, that would be the value you can easily calculate that. When we will be calculating the errors, when we will be talking about the errors, then I will tell you this thing. And this is the global error, and Simpson's 1 by third rule and the global error, the expression for this would be of this form, right? So let's talk about this example, a to b f of x dx, and you are going to estimate it via Simpson's 1 by third rule, and you have this expression, right? So you have this polynomial, you have this formula f naught plus f2 plus 4f1, you have this function f of x whole. You can easily find these values f naught, f2 and f1, and when you will calculate all these values, since there would be no error, because in this case if you have this fourth derivative, this function f of x, first derivative, second derivative, third derivative, and then fourth derivative is equal to 0, it means the error in this case is 0. So we are just going to find these values f naught, f2 and then f1. In this case, f naught would be 1. When you will put the values, the first point would be 1, and this f1, that the second point would be 2. How I have calculated? Because the difference would be h, and step size 1, 2, and then 3. That would be the 3 points in this case, right? Because there is a equal distance of h is equals to 1. So the first point would be this, and the second point would be this, and the third point would be the final point, that is at point 3, the point 3, that would be 25. So just put in the values and get this answer, right? So that is you approximated, and that would be definitely equals to the integral if you evaluate this integral analytically, right? Because you have used this. The error in this case again is 0, because the fourth derivative of this function was equals to 0. The main task is to calculate these points f naught, f1 and f2, right? So thank you so much. You can I will just tell you the exercises in the end. You have lot of material available on the internet as well, the solved examples related to this. Please do those and just tell it to me, right? Okay, thank you.